Hi, good morning, everyone. Welcome to this session, part 2 of data algorithm and tools for LCA, current practices and future development. My name is Franco Donati. I'm the host, and this session specifically focuses on next generation LCA tools, unveiling the latest developments and solutions. We have 4 great speakers today. So we have Fabian Lechtenber from who's currently almost done PhD student at the University of Politècnica of University of Catalunya, but soon going to be a postdoc at ETH. Then he will be talking to us about the PULPO software. Stefano Merciai will follow. He's a scientist at 2.0 LCA, talking about the BONSAI platform and database. He will be followed by Robert Pell, who is the CEO of Minviro. Will introduce his work and the work of his company, and we'll close the session with Chris Mutel, who will tell us about who's a scientist at Collagen Solutions, and will tell us about the data liberation toolkit. I hope you enjoyed the session. We're going to start with Fabian, and well, enjoy it.
All right, just 1 second to share my screen. Do you see the screen? Yeah, okay, I will switch to the presentation. You can also see the presentation now, I assume. So, yeah, thank you so much for this introduction, Franco, and for granting me the opportunity to present to you all today the lifecycle optimization methods and tool PULPO that we developed. Now, when we talk about lifecycle optimization, process systems engineers like myself may think of an approach where aggregated indicators from LCA studies are incorporated into complex process or energy systems models in the form of additional constraints or objectives. Such integration allows the process models, such as this simple reaction separation system here, to account for environmental criteria alongside the traditional performance metrics. Now, while working with the LCA methodology and interacting with the community, I realized that the indicators and tools can greatly support the systems engineering work. But I also found that there is untapped potential for the systems engineering expertise, aside from the provision of process data for inventory construction, to enhance decision-making within the LCA scope, effectively further bridging the gap between the two communities. Now, extensive amount of environmental data is being collected, but traditional LCA methodologies are somewhat limited in the scope and questions they can answer. In response, advanced methods have emerged, broadening the insights of LCA, and these and other techniques are now state-of-the-art in the field. One approach that remains underexplored is optimization. Lifecycle optimization, building on top of inventory data, has the potential to pinpoint production systems that achieve the best possible outcome, meaning minimum impacts, while also considering constraints, tangible constraints, such as resources, capacity, or impact constraints, which is something that traditional LCA matrix-based operations cannot easily do. So optimization within the scope of LCA isn't entirely new, and a couple of frameworks have explored it. However, most of these are either too specific to appeal to the wider industrial ecology audience, or are not readily available for anybody to easily use. One approach, which has been used in many high-profile studies, such as the Plastics Within Planetary Boundaries paper published in Nature last year, is the so-called technology choice model. The underlying idea for this approach dates back to the rectangular choice of technology approach, which comes from the field of input-output assessment, which has then been combined with ideas that have already been formulated in the 2002 book, The Computational Structure of LCA. Now, this approach elegantly converts the matrix-based LCA structure into a linear program, and I will now show you how we build upon that. So here you can see the base model, which includes key data structures and equations from regular LCA, that is the technosphere matrix, the biosphere matrix, the characterization factor matrix, alongside the functional unit vector F. The main difference now from standard LCA lies in the technosphere matrix. Normally, as shown here, this matrix is a square and invertible, mapping each row, that is the reference products, to the columns, that is the production processes. Now, the power of optimization comes into play when we add choices in A, making it rectangular with more columns than rows. In the original approach, this data has been compiled manually in a spreadsheet from various sources in a sort of bottom-up fashion. Now, in this example here, I consider that the heat in this simple methanol production system can be supplied by two different boilers. And in such a setup, optimization becomes useful and necessary, as it can use a guiding objective function, which would allow us to find a unique and optimal solution. So this bottom-up approach gives the practitioner full control over the production system, but can be tedious for complex problems with many products, processes, choices, and constraints. And to address this, I proposed a top-down approach to assembling the matrix. Rather than starting from the individual inventories, as in the bottom-up method, this approach uses the entire lifecycle inventory database that is stored in the user's projects. Choices can then be incorporated by summing up rows of identical products as needed for the goal and scope of the problem. We have further adjusted the optimization problem by adding constraints like lower bounds, environmental flow limits, and multi-criteria weighting in the objective function. But the key innovation from my point of view here is this top-down approach, which is supported by open source software, as I will explain briefly. So here's the overview of the architecture of the PULPO workflow and its implementation. Now, PULPO stands for Python-based user-defined lifecycle product optimization, and is also the Spanish word for octopus. To define a lifecycle optimization problem with PULPO, 4 user inputs are required. The functional unit, as in any regular LCA, the objective function, that is to be minimized, which can be any impact category, granted that you have the characterization factors available. Then the choices need to be specified, which are the processes that yield the same function that can be chosen between, for example, the boiler options from the previous example. And finally, additional constraints can be specified. This would then constitute the goal and scope definition of lifecycle optimization problem. And the rest of the action happens under the hood of PULPO, using a range of open source Python packages to do the heavy lifting. Now, PULPO retrieves the necessary data from the user's projects that are stored in Brightway. With this LCA data then and the user inputs, the optimization problem is created and solved in Pyomo, which is another open source modeling and optimization package with a huge momentum in the systems engineering community. And finally, the results are either saved in full detail or conveniently summarized in the Python console. So one key advantage of this developed approach is its ability to handle large-scale decisions and feedback loops. Typically, practitioners model a foreground system against a fixed background system. Now, with PULPO, enabled through this top-down approach that I explained before, choices can be introduced both in the foreground and in the background. For instance, if we are optimizing an electricity mix, we cannot assume that the background data still uses a non-optimized mix, as this would create inconsistency. In an example that we addressed in our paper, we observed an 8% difference in outcome between the integrated and non-integrated approach. And other studies, such as this recent one here from my colleagues in Zurich, showed errors of up to 35%, highlighting the need to consider not only how the background influences choices in the foreground, but also how the foreground could influence the background if the scale of the decision is sufficiently large, effectively blurring the line between the two systems. Now, in one case study, for example, we demonstrated how PULPO optimizes a sector-coupled system for global electricity and methanol demand, considering that carbon capture and utilization could be used for methanol synthesis. The functional unit here represents the global methanol and electricity demands, with the objective function minimizing the global warming potential as specified by the IPCC. Key choices include the selection between business as usual methanol production via steam methane reforming, or synthesis of methanol from captured CO2 and electrolytic hydrogen. Additionally, the model considers whether to retrofit existing fossil thermal power plants with carbon capture, which then can be utilized to supply the CO2 for the methanol production. Other modeling decisions include the use of a prospective databases generated via premise as backbone for optimization, and the assessment of upper limits on availability of electricity. And for further details on modeling assumption and rationales behind certain decisions, I refer you to the paper, or you can ask questions. Now, the results for this case study indicated that the more stringent the decarbonization scenario, the more important the circularity of carbon via direct air capture. In these graphs here, we could also see how the targeted impact category, that is the global warming potential, drops as a function of availability of electricity that is needed to run the CCU process routes. While our primary focus was on global warming potential, we also assessed other indicators to account for burden shifting. In this particular case, no significant shifts were identified in the recipe endpoints or environmental footprint indicators. So from my dissemination of PULPO so far, I received encouraging feedback, and we're aiming to apply it to more cases where it can lead to useful insights. And I would be happy to get in touch with anyone who may think that the approach may be useful for their specific case. And as Franco mentioned in my introduction, I'll be dedicating my postdoctoral research at ETH Zurich to developing and disseminating PULPO and working on lifecycle optimization problems, further bridging the gap between the industrial ecology and process systems engineering communities. Now, here you can see just some of the steps that lie ahead. A big achievement that would be to integrate economic and social indicators. Conceptually, this would be straightforward if we had the data of the three pillars in a harmonized format. I'm sure that looking into the literature of life cycle sustainability assessment and input-output assessment will give me hints on how to achieve that, but this is one of the many points to be explored in the future. So here's a list of references and resources you can use to learn about lifecycle optimization and PULPO. A recent addition here is the workshop material that I prepared for the BrightCon conference, which provides an information ranging from the theory behind LCA and optimization over a simple example to follow along, all the way to a practical exercise allowing you to test your understanding of the approach. Now, I should stress here that at the moment, all of this is only available in Python, and as we build upon these convenient packages like Brightway and Pyomo. However, I think that if we find that the approach raises significant interest and demand, I believe it has the potential to also become an asset in other LCA software. So thank you. With this, I would like to thank you for your attention, and I'll be happy to take any questions, comments, or feedback right now, or if people are watching this recording via email on this address that you can see here. So thank you very much.
Thank you so much, Fabian. Are there any questions from the audience or even the speakers? So there is a question in the chat that asks, I'm not sure I totally understood where the limitation of the original rectangular choice of technologies approach. I don't know if you can see the chat, Fabian.
I would have to switch in a different, let me check. Okay, so if I understood correctly, the the original rectangular choice of technology approach has been developed on and applied to exclusively input-output assessment data, right? And later this approach has been adopted to LCA data via this technology choice model approach that I showed you here, I think. Right, to this model, which uses LCA data as input rather than input-output data. I don't know if that answers your question.
Thank you, Fabian. I think we'll move on to the next. I think it provides quite a bit of background. If anybody has questions, can also reach out after the presentations. We have to move. We have a lot of speakers, so we need to move on. But feel free to keep writing questions in the chat should you have any. The presentation will be available after the session as well. So moving on, the next. Thank you so much again, Fabian. We have now Stefano Merciai, scientist at 2.0 LCA with the BONSAI open source platform for product footprinting. Stefano, the floor is yours.
Okay, can you see my screen? Perfect. Okay, so thanks a lot, Franco, for inviting me to this session. So I will, Stefano, I work Merciai, I work for 2.0 LCA, and then I will briefly introduce the work that we are now doing with the BONSAI.io, that is an open source platform for product footprinting. Oh, sorry. I think, sorry, I pressed the wrong button. Okay. So what is BONSAI.io? BONSAI.io is an input-output database that we are developing within the Getting Data Right project that is founded by the Danish KR Foundation and is led by the Aalborg University. The BONSAI.io is like a database that could be used as a background database when you are doing life cycle analysis, or can be used for the calculation of impact of regions, the footprint of products, if you want to perform scenario analysis, and many more usages. Perhaps some of you are, I will introduce some words on what is input-output, because I know that this is industrial ecology, so some of you might not know what does input-output means. Perhaps you are more familiar with diagrams where you have activities that are exchanging, that are producing product, that are exchanging product with other activities, that are transforming product, that are going to consumers, and then consumers can have production of waste, activities can have production of emission, and so forth. If we organize this information that we have in a diagram into a matrix, where on the rows we have activities and the columns consumer, we have an input-out table. If we have also exchanges with the nature, we can have like the emission, extraction of resources. We also have the input of a primary factor that can be labor, land, capital. So you can think about an input-out table as a big technology matrix that is, I'd say big because it's built for countries or regions. And sometimes we also have many countries, so we have also exchanges between countries. In this case, we refer to multi-regional input-out tables. Of course, because we are putting everything in one matrix, we have to perform some operation that is often we have to reconcile data, we have to homogenize, and we do the balance. And BONSAI.io is a multi-regional input-out database And it's multi-layer because we are multi-layer. This means that we are using several units. So we are using monetary units, currencies as euro, but we are also using tons, terajoule, and items and whatever. Now, what are the principles of BONSAI IO? First of all, transparency. Indeed, our code is uploaded on GitHub and is open, so you can see what we are creating. So you can see on GitHub, on our repository, the different, module of our workflow, from the collection data, from the cleaning, the load, the building of input-out table. Everything is public and is uploaded on GitLab. The same time, we want to have we really think that it's important traceability of data. So we publish table, all the data sources that we are using, so that you can really see what is the raw data that has been used, how is it transformed, and till the final database. And everything that we produce is open source. So we have created the APIs that you can use to download everything that is provided BONSAI IO. So there will be API to download the classification, the footprint that we are creating, but also the data. So if you want to download the entire data set, you can still do it. And of course, we want to have something that is easy to update. So we are working so that in the future, we don't need a lot of maintenance if we want to create, we want to update the database. And also we are putting a lot of effort in documentation. So that can be easily understood by the user. And another thing that we find very important is as to be really user friendly. So we usually the input-out table is not easy to manipulate. So we have changed the structure of the input-out database so that it can be easily manipulated by the user. And of course, because this is an open source platform, we are really keen to have contribution from the community. Now I will tell you a bit on how we change the structure of input-out database to make a tool that is more flexible for and more friendly for the user. I will do two examples. For example, let's assume that we are producing bread and milk and we need wheat as an input. Or we are producing bread and then we need some heat. So I will introduce the concept of markets of products and the modularity that we inserted in BONSAI IO. Usually, when in a normal input-out table, you have that all the suppliers are linked to the user, and so in this case you have many arrows. So in this case, wheat can come from different suppliers, and so you have many arrows. We have introduced the concept of market. So the markets collects data from different suppliers, and then the user purchase directly from the markets. In this case, if we want to look at the matrix that we are producing, the common input-out table, the common input-out table, the matrices are really dense. Instead, in BONSAI IO, the matrix will, so the input-out table will be really sparse. But this also facilitates, if you want to implement some scenarios, because if you want to change some disruption or some change in a supplier, you don't need to change many values in your table, but just one value, and so facilitates the work of when you want to do some scenarios. And the same thing also, we are making a database that is more modular, because usually in input-out table, you have that you can only visualize the total emissions of one activity. So in this case, let's assume that to produce bread, we need some heat, and this heat is coming from several sources. If you just visualize what is the total emission, you do not really know what is the source of the emission. While we have changed the structure in BONSAI.io in the input-output so that we have, again, markets, and then the markets are using combustion activities, and each combustion activity will produce specific emissions. So in this case, you can play with different mix, and you can see exactly, directly what will be the change in the emission. So it's more transparent and it's more prone to be to the implementation of scenarios. Now, of course, this is open source platform, and so we are collecting a lot of data from different data sources. And but of course, in the future, because it's open source platform, it will be really nice to have contribution from users, and this contribution can come with the production the data that can be in any unit, in mass, in an item, in currency, whatever. But also will be great to have also from the contribution parameterized production function that is just nothing more, that is like the function that describes how products are done. So all the relationship between input and output that can come from life cycle inventories, from PhD thesis, from literature, and from whatever, and also code. As you saw, the code is completely open with you see the repository. So if you want to contribute in the future with the code, you are very welcome. And we have also, like for example, for parameterized production function, we have like a session in our repository that is dedicated to this function, where you can, there are packages that you can also download and then you can use in your study. So it's something that can be also used outside BONSAI.io. Finally, what we are now we have just created the beta version. The project will be finalized at the end of June. So we are now working for the first version that will be released soon. And then we have created a web interface where you can play with the numbers of the, for example, you can, if you want to calculate the footprint of production of the food, you want to see the footprint of a market for a specific product in one country, then you can analyze, then you can see the footprint, and you can also see what is contributed to this footprint, and you can navigate, and then you can play with a bit with the number. In the future, we are also want to insert, now they are the dead bottom, but the idea is to have in future the footprint of countries, so that you can have the total footprint of a nation, the total footprint of the consumption of household, of the government. And you can do also comparison, and you can have a time series of for different years. I think that's all from my side.
Wonderful. Thank you so much, Stefano. Are there any questions from the audience or from the speakers? No, it seems. So Stefano, then do you think how do you see the interaction between the input-output community in a way and the life cycle assessment community through this database? Because it seems almost as if the two communities are basically coming through together through this the development of this database and tool. What are your thoughts on that?
Yeah, the idea of BONSAI.io is to create a bridge between the two communities, and so to create a platform that can be used by both the input-output and the industrial ecology community. Yeah, because our idea that, we share I'm coming from an input-output community, so I ended up in industrial ecology by accident, but I think that we share a lot a lot of methodologies, and only that I think sometimes the input output is taught as pure economic tool, but at the end is very flexible and can be adapted to the need of industrial ecology community. And so this work is really to create this bridge between the two communities.
Wonderful. We also have time for one more question. I think are other greenhouse gases except for CO2 considered in this database?
Yes, we have other gases. They say the first version we are focusing on carbon footprint because this was the target of the project. But of course, we also have other emission, and we plan to integrate more and more emission. Also, we have also to include water, land, water use. And we also have now land use, and yeah, our plan is to integrate more the extension so that we can have more footprints.
Wonderful. Thank you so much, Stefano. We'll move on. It's a very tight schedule. Thank you. We'll move to Robert Pelsiot and Minviro. He will talk to us about the 𝐋𝐸𝐬𝐚𝐥 elevating LCA with quality, collaboration, scalability. Thank you.
Cool. Thank you so much. Really interested. Really thanks for the invitation to present and really interesting talk so far. Yeah, so I'm founder and CEO of a company called Minviro. We do a lot of commercial LCAs across the energy transition. So we work with companies like Tesla, Rio Tinto, and all those that are really providing materials or providing technologies for the low carbon transition. And we've been delivering this since 2019 as a spin out from University of Exeter. And what I'm going to demonstrate today is a product that we've developed, which is kind of formed out of all the workflows that we've done over these years to develop high quality LCAs. And there's a couple of innovations specifically that I can talk about. So one I'll talk about is AI. So everybody talks about AI and what's the opportunity for AI in LCA tools. And the other one is around, okay, well, how do we improve better quality data? So when I talk about data, I'm talking about how do we get better quality inventory data, not just in the foreground system, but in upstream stages of a supply chain. And I'll also give you a quick demo of our platform as well, so you can see that in practice. But I think there's been a lot of discussions and excitement, especially in sort of the LCA community I've been in around AI and LCA. And there's really three opportunities that I see for AI and LCA, which is accelerated modeling, so sort of streamlining that. But that also leads to greater need for expert validation. So we've done some testing against our primary models, and we've obviously seen that there's data quality issues. But there's also a big opportunity for streamlining complex tasks. So things like data quality indicators or mapping characterization factors, which are repeated across models. And I can kind of show you this in our product as we go through. But some things that really need to be considered is there's no point implementing these AI system improvements unless we have good data. And this is kind of what I'm going to present as well with collecting better quality upstream data. Because when we do commercial projects, say with a battery manufacturer or the downstream, we often find that big hotspots and sensitivities are actually maybe in a refinery upstream. And traditional methods of LCA have utilized industry average data points, but really the range of impacts for, say, nickel sulfate production, like the carbon intensity of nickel sulfate production can be 20 times different depending on a low source nickel sulfate production versus a high source nickel sulfate production. So what we really think about is AI needs to be able to understand the nuances of these sensitivities in models before we're trying to automate all this process. Also, just some other bits around, like it needs to be a community-driven effort with interoperability, which I think many sort of people are talking about here, and sort of data-centric AI there. Because I only have 10 minutes in total, I won't talk too much about this, but we basically, the conclusion that we've drawn from AI implementation in our software is that the goal should not be to replace the practitioner, because the practitioner have their expertise in specific sectors. but it should be used to reduce repetitive tasks and improve modeling speed and uncovering insights that would otherwise be hidden. So that's kind of the conclusion that we have from AI in integrating into our software. But these are some of the fundamental challenges that we've got broadly about LCA software and LCA modeling generally from our community and from the LCA practitioners that we've worked with. So there's still sort of interface developments that are required to make it more user-friendly as LCA becomes more sort of mainstream and commonplace for commercial companies to use. More teams need to be using LCA software, so it's not just an LCA practitioner, but it might be procurement or R&D or even the C-suite that need to understand the outputs of LCA studies. There's big data issues, so we've got more and more data that needs to be harmonized and connected in different ways. That data might be coming from company systems like ERP systems. And again, that last point is really similar about sort of the visual representation of the modeling software. I've got a very quick video. Let's see if this works, but just to sort of introduce the software, then I'll go on to the demo.
We've spent months listening, testing, and perfecting a tool designed by LCA practitioners for LCA practitioners. Meet Cycle. Cycle is a tool for high-quality, collaborative impact assessment. It enables LCA practitioners to model efficiently, communicate concisely, and make decisions collectively. Get in touch and get access today.
Cool. So
We've spent months listening.
Stop repeating that if you really don't want to see that twice. But now I can jump into the software so we can kind of do a live demo. So it's quite similar to some, existing softwares in terms of you've got sort of that visual interface, understanding sort of the material flows. What you're seeing at the top here is sort of a cell manufacturing process going right upstream to nickel sulfate production. So looking at a battery production system boundary. We tried to create an ecosystem where all the information is sort of accessible for the fingertips of LCA practitioners. So you kind of have your inventory items down here. You can connect directly and it automatically generates impact data on the fly. So for example, if we're looking for, I've just disconnected this characterization factor, but now I can research this and it will be researching the databases that you decide to connect up. And it's as simple as mapping that and you'll see it automatically calculates impacts as you go along here. But that's really sort of for informational purposes. Another thing that's pretty useful that we found as a challenge for LCA practitioners is actually understanding the data. So we have map, but we also have open, which brings into the dashboard sort of the metadata around these data points. So in this instance, this is 𝐬𝐭 data, but we try and connect broad ranges of data in here. So you can have a very rich data set, including primary data, which I'll show you in a demo in a moment. But this metadata can be really useful because it can highlight, okay, well, is this the right data point to connect? We can look at the project information, the start date, the end date, and then we can look at sort of the big contributors. We can even go sort of further into this data point and look upstream at the major contributors to this supply chain impact. So we can look at this for climate change, but we can also look at this for the selection of impact categories that we decided for. So maybe we want to look at the freshwater ecotoxicity contributions upstream of this particular copper collector foil production. So super valuable. You can also add notes to the model, and that's really the challenge we've seen around the critical review process and having that disconnected from the model. We've tried to solve that. So say, for example, if we're not happy with this particular data point and we want to open this up, and as a critical reviewer, we say there is not sufficient evidence for the source of this material. Like it could be any comments like that. We can also look at result visualizations instantly, and not just for the final product, but we can sort of subcategorize to any sort of reference flow from any of the unit processes. So, sorry, looking at cell waste there, let's look at cell production. So you can see the model here looking at the different stages of production, and then we can look at different impact categories. Again, we can look at impacts by unit process or even by inputs if we want to see sort of a more granular breakdown, and we can look across a range of impact categories as well. So maybe we want to look at particulate matter formation, for example. And you can see some system expansion being applied in this particular model. So you see some credits being applied there. Now, I mentioned around improving how we can bring data into models, and we do this through our integrations. So we have integrations with external traceability solutions and other systems, but we also have our own one, which I'll just show you here. Now, I'll just repeat what the challenge is. A lot of the time when we've done commercial LCAs with battery manufacturers, they're not, depending on where they source their material from, they can be purchasing, spending a lot of time and investment, making sure they get supply chains set up with lower impact material suppliers. And collecting that primary data is very, very important. And so what we've got here is a traceability solution where you can create custom data collection forms for different actors within supply chains. And what you see here is a very simple Kanban of maybe data collection requests, and I can just open this up. So fundamentally, you would submit this to a particular contact that you have. So you can see I've asked for nickel sulfate in this instance. There's some information guiding the company, what information they need to fill in. And then this is kind of like a familiar inventory template where the customers would need to fill out this data and submit, okay, well, how much are they consuming for this period of time? This can be critically reviewed like in the platform, so we can add comments and have review points, and we can actually have an auditable process in this, so we see all the activities that's taken place within this data collection process. So we can see over time how that happens and basically question particular data points as they come in. So once you're happy with that, that can be sort of validated and approved, and then I'll go back to the cycle model, and then that could be pulled in automatically to this particular data point. So we're able to automate that data collection and pull through primary data for the LCA modeling experience. Cool. I'll go back to the presentation because it's just one more slide, which is just around sort of an LCA community. So here's some, if anybody's interested in sort of contributing to an LCA community where we're talking a lot about methodology, a lot about regulations, a lot about sort of how LCA can innovate over time and support in making positive change in the industry, especially, then feel free to join. Either send me a message or you can jump on the QR code there and I can add you to the community. We're also open for those who want to get trials on this software. So if you're also keen for a trial, just reach out and we can get you set up. Thank you.
Great. Thank you so much, Robert. As I expected, there are quite a few questions, or 2 questions at least. I think the first one is about, do I understand that there is a LCA software with a graphical user interface like CIMA Pro or OpenLCA?
Yeah, it's similar. I suppose some of the things that we're trying to innovate on is how do you improve better quality data coming into the system? How do you encourage collaboration on the platform? And collaboration is between users, so it might be within the same company or across companies. So a Tesla battery manufacturer with a mining company upstream, how do you collaborate on an LCA across actors within the supply chain? There are sort of that visualization aspects which are commonplace across other LCA softwares.
Okay, great, thanks. And then the other question is about actually the integration of AI and data quality. I think I'm not sure if you can read the questions, but yeah, if you can speak a little bit more of in that regard.
Yeah, it's a really good question. So we have done some modeling on that, and you can actually get some scoring parameters in there. So like, what's the quality of the output? And one of the things that we trialed is like, okay, you can, as a user, you can specify your quality acceptance of connecting the system to the background characterization factors. So you might want to set a very high threshold, like a 95% scoring. And then anything below that, you kind of need that manual connection. It's kind of similar to like a completely different sector, like accounting reconciliation, where you still need a manual reconciliation confirmation when you're connecting data points.
Great, thank you. To me, it wasn't. I have a question as well. To me, it wasn't fully clear exactly how then actually artificial intelligence is integrated within the calculations or with the methods that you're using, and to what extent also, well, uncertainty might be, the quantification of uncertainty is integrated into this model. If you can speak a little bit of that to that extent.
Yeah, for sure. So there's a few ways that we've trialed AI integrated into the solution. So one is we created a very simple sort of like ChatGPT-like prompt. So then we were able to build models with prompts rather than from like conventional model building. What we found from that is that it's very good at like providing the broad brush like approaches, like what are the main stages of battery production? What are the main stages of making a machine? What it's not so good at is creating good, accurate, detailed inventory data points. So like it's not very good at estimating the energy consumption for a unit process in a specific context. We've also been trialing basically that mapping. So the automated mapping between once you type in an inventory and finding a suitable data point from the databases that you bring in. That's where I think it can improve quite a bit. Another area which I think it can help a lot with as well is between sort of like, so data quality indicators you asked about. So we have the, a typical sort of, the approach that we use because we're trying to align with EU regulations is the data quality indicator approach for that one. But challenges also exist between how do you harmonize data quality indicators if you want to report using a slightly different methodology. So that is also a useful application of it, but that's not really deep AI. That can be quite simple calculations. But yeah, really filling data gaps, I think, is useful. And actually, I think another opportunity is from the previous presentation is like, how do you optimize systems? I think that's another big opportunity with how AI could be used.
Wonderful. Thank you so much, Robert. Thank you so much for the presentation. We'll move on to the next speaker. So we have now Chris Mittel, who's a scientist at Cauldron, but also the creator of Brightway, who will talk to us about Data Deliberation Toolkit. The floor is yours, Chris.
Thanks. So, sorry for this. I had everything set up in presentation mode on the notebook, and then it literally broke as I was trying to share my screen. So we're just going to have to look through this the old-fashioned way. The Data Liberation Toolkit is a set of open source tools that I and Cauldron have developed to try to make data flow more easily within the LCA community. Those of you who are experienced know that this is much more painful than it needs to be. So the first tool is an interface to be able to use 𝐈𝐭 in a programmatic way. 𝐈𝐭 currently doesn't have an API, so we built one based on the way that their website currently works. This is unofficial. 𝐈𝐭 could choose to break it at any time, so nobody is making any promises. Of course, you need an 𝐈𝐭 license to be able to log in. That can be done in multiple different ways. I have mine set permanently, so I can just create my settings. Restart this just to make sure nobody is cheating. And then from this, you could do the normal types of tasks you would expect to be able to interact with 𝐈𝐭. So I can list the versions that are available. I can ask for the system models in 3.11, which came out yesterday or 2 days ago. I can also do this in the non-translated way, so the full system models. And then I can specify what kind of release I'd like to download. So they have not only the 𝐈𝐭 files, but they have a whole bunch of gigantic Excel sheets. If that's your thing, then you can do that. Then if I wanted to download the complete release, I would just call the get release function, and this would not only download it, but also extract it and also fix it. So we don't normally have to do much with modern 𝐈𝐭 versions, but we do read in the XML files and actually set the version numbers to be correct because somebody has to. Then there's other ways of working with that. So for example, you can interact with individual processes. So in this case, I'm going to say I would like to work with 3.11, again, using APOS. And I can select by either a dataset ID, that's an internal 𝐈𝐭 ID thing. You can use its file name, but you could also specify, for example, attributes of the file, like its reference project, its location, its name of the process, sorry. And then I can use that to get basic information. But it's not just that. You can also get, for example, the 𝐋𝐨𝐬𝐷 XML. You can get the inventory and impact assessment 𝐋𝐨𝐬𝐷 XMLs. You can get the PDF, and you can also get the undefined PDF. And this works for all system models going and all versions going back to version 3.0. There's a whole bunch of other stuff you can do, but the time is limited, so I'm going to move on to the next library, which is 𝐈𝐭 Migrate. So 𝐈𝐭 publishes a spreadsheet, which gives you some information that you can use to try to do translations if you were, for example, building an inventory on version 3.10, and now 3.11 is available. But this spreadsheet is not usable in a programmatic fashion. So 𝐈𝐭 Migrate would read in the spreadsheet. It would also download using 𝐈𝐭 interface versions 3.10 and 3.11 and supplement the spreadsheet with additional changes which are not included in the change report. and then prepare that in a file format, which is the subject of the next library, which is called Randonneur. So Randonneur is a library to make changes to lifecycle inventory databases. This is something that we all have to do quite a lot. Anytime we do harmonization, anytime we do maintenance, we need to make some changes. Usually there are two edges, sometimes there are two nodes in the supply chain graph. So Randonneur is both a specification for what this should look like, building on existing specifications, but also has a reference implementation. One thing which is very important is that the Randonneur metadata follows the Open Knowledge Foundation data package.json standard, which means you have to specify who authored the data, and you have to specify a version, and you also have to specify the license. This is something which you normally don't see, for example, in these Excel sheets, or definitely not in any systematic way. So if we're doing mapping, if we're doing transformations, then we need to have a way of defining not only what we call a specific data attribute, but also what that specific data attribute is called in the original source data. And the way that we do that is building on, again, existing open source technologies. So for example, we can build on top of XPath or JSON path to be able to look at the original source data and say, okay, we're going to use the label name. So where is that exactly specified in the XML file? And the same thing with, for example, UUID or any other data attribute, which would be useful for us either for selecting or for specifying what the new values should be. We also have invented a JSON path-like format for working with SEMAPRO CSV. And then when we are doing transformations, it's nice to be able to specify what the source and target is, because we don't have a common way of defining these. At BrightCon a few years ago now, we defined a common identifier standard, which is very simple. It's just the name of the location, or name of the database, then its version, and then any other additional specifiers. And this format can be used for the standard CRUD operation, so create, replace, update, and delete, but it can also be used for disaggregate, which is a specific type of functionality needed for lifecycle inventory databases when you go from one process in a certain version to many processes in another version. All this is very theoretical. Let's see what it looks like in practice. So we can load up the Randonneur data, which is the fourth library in the data liberation toolkit. And that's basically just a collection of common transformations which we need when we're working with common LCA data. Load up the registry, and let's take a sample. So we'll start with a sample from going from 𝐬𝐭𝐢𝐿 version 3.8 to 𝐬𝐭𝐢𝐿 version 3.9, looking at the biosphere. So what kind of changes do we see? First, we can see a delete change. So they decided to remove a certain format, certain flow. So we have two of those. So if you wanted to do a migration, then you would need to remove any references or decide on your own what it is that you chose to do. Of course, Randonneur doesn't always apply everything. You can specify which verbs you want to follow, and you can customize basically the behavior of everything. Then we have some replacement. So in this case, the name cadmium was replaced with cadmium-2. The formula was also changed, but the UUID stayed the same. So that's definitely something to be aware of. I wouldn't necessarily say that's best practice because this seems to be a fundamental change in the flow. But one thing which is important to notice is that this isn't something which was supplied in the change report. This is something we noticed on our own by manually inspecting the 3.8 versus 3.9 biosphere databases. And you can see the same thing here. And of course, this is just a random sample. So every time we look at it, you're going to see something a little bit different. So here is the schema for where it is exactly we find these. This is definitely not human readable. This is rather complicated XPath expressions, but these are something which you can apply directly against, for example, the elementary exchanges.xml file. Now let's look at another transformation. So SEMAPRO going to 𝐬𝐭𝐢𝐿. This is a classic problem because they have very different types of data schemas. So first we have to look at the changes in the context. So that would be, what do they call emissions to soil, for example? That's just called soil in 𝐬𝐭𝐢𝐿. It's called emissions to soil, but also sometimes called soil in SEMAPRO, but with a capital letter. And then we can look at changes in the Okay, the process name. So here's a classic SimuPro name, which is not just a name, but also a location and a reference product and a market identifier and a system model all at the same time. And we have baked in for versions 3, 6, 7, 8, 9, and 10, I think, although don't hold me to that, translations which allow that to disaggregate. So here is the original name, and you can see that this is not just a shortening of what was available. Yeah. In this right here, but it's yeah, it has additional detail, and this would also give you the file name, which would be enough to uniquely identify the source of the information, so that if you wanted to do a translation from a SimuPro file to an 𝐬𝐭𝐢𝐿 file, you would be able to do that. We have a similar thing looking at the differences migration of 𝐬𝐭𝐢𝐿. Here we have a disaggregate. So disaggregation is when 𝐬𝐭𝐢𝐿 says, hey, we took this one process and now which was global, now we split it to a bunch of different locations, and we generate the allocation values by loading in the database and looking at the production volumes of these different processes so that you can do automatic disaggregation. Speaking of SimuPro, we have a new library for parsing SimuPro CSVs. This is a very interesting and challenging format to work with because it's not a pure CSV the way you might be thinking of if you are just learning about data engineering. And we've tried to solve a bunch of those problems. Let's look at what this looks like and when we integrate all these together. So this is a notebook I'm not going to run now because it takes a little bit longer, but this is a notebook importing 𝐸 version 3.1.1. So we can start a Brightway project. Oh, by the way, all of these things are completely independent of Brightway. Sometimes they use Brightway, but you don't have to be a Brightway user to use them. You can use them in any generic software framework toolchain. In this case, we will be using Brightway, and we would load in a project which has 𝐸𝐭𝐢𝐿 3.10 and 3.8. That's because 𝐸 was developed against 3.8, but we want to be able to migrate it to version 3.10. So we would load it in using our new SimuPro block CSV importer. It's going to give us some log messages, but actually these log messages look quite good. It means that we don't have any fundamental data problems, which sometimes you have in SimuPro CSV. Then we're going to start applying these transformations. So the first thing we're going to do is 𝐸 has a bunch of aggregated 𝐸𝐭𝐢𝐿 activities. We're going to delete all of those, and then we're going to relink what the internal 𝐸 edges to the original version of 𝐸𝐭𝐢𝐿, version 3.8. Then, I mean, there's a bunch of other stuff happening here, but after that, we can say, okay, now we were able to take these aggregated 𝐸𝐭𝐢𝐿 activities, delete those, relink them to 3.8. Now let's migrate from 3.8 to 3.9 and migrate from 3.9 to 3.10. Then we would have the original 𝐸 data that's now linked against now not the most recent version of 𝐸𝐭𝐢𝐿, but the second most recent version of 𝐸𝐭𝐢𝐿. And we have to do a bunch of specific things because, of course, none of this stuff is simple. We have a bunch, especially when it comes to biosphere, we have a bunch of manual matches. We have a bunch of automatic matches. We have some special cases. We have to deal with the case, for example, that SimuPro has decided to regionalize elementary flows, but in a way which is very difficult to deal with. But we have, anyway, so you apply a whole bunch of these different types of transformations, and eventually you come up with a final database which looks like this. So we would have 𝐸 linking to 𝐸𝐭𝐢𝐿 version 3.10, both the biosphere and the cutoff. It would include multifunctional data sets, which is new, at least in the Brightway framework. And we would create some additional sort of proxies, which allow us to express regionalized information, but in a more correct way. And we have some placeholders for things where we just didn't want to put in the time to manually match SimuPro biosphere elementary flows against 𝐸𝐭𝐢𝐿 elementary flows, or for cases where there weren't ones. And eventually we decided this is enough. You never really get to perfection when you're doing harmonization across systems, which are so different. And so then we would get a little bit cheeky and just delete. Actually, there's only one exchange which is completely deleted. Everything else, we create a proxy that says, hey, if somebody in the future has way too much time on their hands, then they could try to continue to do this manual type of matching. So with this, we are able to import 𝐸, link it to a recent version of 𝐸𝐭𝐢𝐿, and be relatively confident that we're getting scores which are at least comparable. All that stuff is, all these libraries are free and open source, and well tested, following best practices, et cetera, et cetera. We are happy to support your company if this is something that you would like to do at scale, because even though this libraries are open source, it doesn't mean that you don't need a little bit of hand-holding. LCA data is still way too complex. It's another thing that we hope to be able to solve going forward, working together with the rest of the community.
Great, thank you so much. Thank you so much, Chris. Are there any questions from the audience or from the speakers? In the Q&A. Oh, there's one. Are the notebooks on the 𝐷epartment GitHub?
The notebooks are will they'll be showed on the Zenodo. So there's a special Zenodo archive just for ISIE Day. And each one of those libraries has basically the notebooks are just copying and pasting from the READMEs of the different libraries. So just look at the different READMEs. Yeah.
Thanks. I also have a question myself. So you've just shown that you have done the deletion of some aggregated processes that you have within agree values, and then they get connected to a different version of 𝐋𝐸 that has maybe it's more disaggregated. Then do you also have the possibility to reaggregate it according to the agree database, or do you maintain them disaggregated, or do you have the flexibility to actually move from one to the other?
Yeah, so the reason that these are aggregated or system processes is due to licensing constraints. It's not a desired effect of the system. So the point there was, if you want to link against 𝐸𝐭Invent, let's allow you to actually link against 𝐸𝐭Invent. So you can either traverse the supply chain and see where the origins of the impacts are coming from, or you also have the opportunity to not only link against the original 𝐸𝐭Invent version, but against the most recent version, which is available, which theoretically should be higher data quality.
Great. Thank you so much. I think we're reaching the end of the session. So unfortunately, we have to go. But I wanted to thank the speakers for their time for making the presentations, and the audience for the questions and participations. The recording will be available through the Society of Industrial Ecology and also the slides. Thanks again, and then hope you found them interesting. I definitely did. And thank you again, the speakers, for presenting. Have a good day.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.